Hi guys, today we're going to review the district math practice assessment. The purpose for this video is to give you guys strategies to take the real district math assessment, which will be in the coming week. So same exact problems, just different numbers. First off, let's take a look at question number 1. You can see there's 5 possible answers. That tells me there's probably going to be 2 correct answers, maybe even 3. With Common Core, anytime that you see more than 4, the odds are there's going to be 2 or 3, and as you can see right here, 3 that apply. I don't know how many times kids will only answer 1, and it automatically causes them to miss the problem. Another thing I want to point out, as you can see, this decimal has a tenths and a hundredths place, so it is really critical that you line up the place values when adding. This is 3 100ths, 2 tenths, 4 ones, 8 tenths, and then 7 hundredths. As you can see, the 79 and 51 thousandths should be lined up exactly in the same manner. Rewrite these problems. I don't know how many times kids will make a mistake by modifying or moving the place value and not lining everything up. You can add a 0 to the thousandths place. So I'm going to use a different color because I want to kind of show you that once again, you're going to add the thousandths, you're going to add the hundredths, you're going to add the tenths. You will carry that number over if it is larger than a 9. So I'm not going to solve these problems because that's not going to help you on the upcoming assessment, but you can definitely use these strategies. I would really recommend that. The next problem is a ratio. So there's 3 different ways of writing a ratio: 18 tables and 54 chairs. I'm using T and C to identify table and chair. Okay. Now I want to point out once again, there's 3 different ways of writing a proportion. I'm going to use it as a fraction. This is one way, a numerator and denominator, to write proportion. And as you can see, 18, you may not see that, but 18 is actually a denominator of 54 because 18 times 3 is 54. So if you divide both numerator and denominator by 18 over 18, what you will get is 1 over 3. And they try to trick you. They show you 3 over 1, which would be it would actually be 3 tables to 1 chair, and that's not correct. It's actually 1 table for 3 chairs. So as you guys can see, this proportion is correct. The next problem is a word problem. What I would really do is read this multiple times. Read it multiple times, set up that proportion. Once again, you can set it up as a fraction. I think that's probably the best way of doing it, considering that you guys have the most experience with fractions. And as you can see, then it's really just basically finding a simplified number. 240 divided by 4. If, for example, you did not realize that 4 is the common denominator, dividing both sides by 4. What you could do also, and that's obviously division of both the numerator and denominator. Another thing you could do, because these are even, you could divide by 2 and then divide by 2 again, and that would be dividing by 4. So once again, make sure you have the feet to seconds. They don't have 60 seconds as one of the possible answers, but if they did, they would try to throw you off because the answer is 60 feet. We're going to go up to problem number 4. Proportions are tough, but you really got to take your time, write them out, show the relationship. Now take a look. You can see there's a 1 to 2 relationship. Okay, you can look at the number of pages being read to the number of minutes. So that is going to be for every 1 page, 2 minutes. That's a 1 to 2 relationship, and you can see everything is looking good, but in this case, that's going to be a 1 to 3 relationship. So there is a strong relationship between pages read and number of minutes. This one's a little funky. This doubles, so this should be 16 if this doubles 2 times. Here we have 1 to 3 relationship, and this is a 1 to 2. So there is a mistake with B. It doesn't follow the same ratio, a 1 to 2 relationship. As you can see, if it did, it would be 16. So they're asking you 2 that apply. There's 2 correct answers. A and C have a correct equivalent relationship. All of these examples are 1 to 2, and all of these are 1 to 3. This does not follow that example. Problem 5. Once again, man, we're getting hammered with proportions, but this whole district math assessment is all about proportions. Not all about, but probably about a quarter. So $8 per hour. I would recommend rereading this multiple times. This problem, you probably don't need to set up a proportion. You can kind of use your mental math, knowing that she makes $8 or this person makes $8 an hour, that first hour, that second hour, 16. You're going to basically count by eights 6 times. So that's really a multiplication problem, but you could see, as you can see, I'm setting this up just like a proportion. So this could help you to solve that problem. Problem number 6, which of the following pairs of numbers is matched with its correct least common multiple? So I want you guys to think about the relationship of numbers. So least common multiple, think about least as in smallest number that goes into a larger number. Also, when you are skip counting by a specific number, those are multiples. So 4, 8, 12, 16. Those 4, 8, 12, 16 are multiples of numbers that go into 4, meaning multiplication of 4 or division of 4. We're going to move to the next problem. Number 7. Once again, I would reread multiple times. You can see I'm underlining the important information. Percentages. When you think of percentages, I want you to think about out of 100. So usually what they'll do is they'll set up a problem that has a denominator that is not out of 100. And then you have to modify that fraction to make it represent something out of 100. And that's where we have percentage. The next problem is a straight 2-digit division problem. So when they write out this problem, this number is the divisor and the larger number is the dividend. Okay? If you just break it down in that manner and you break down 2-digit to 2-digit division, it makes it really easy. 17 doesn't go into 11, so you have a 0. Now you're going to have a little tough time because you need to figure out how many times 17 goes into 113. What I would do is I would just kind of experiment with the divisor times a number to get as close to this number as possible. And you can see 7 times 6 is 42, and then 60. So we're at 102 where we nailed it. I actually just kind of guessed that if this would go in that number of times, and it did. Number 9, when you are subtracting decimals, write it out vertically. 104.001. Really pay attention to that decimal. I'm going to start with the decimal right here, and then I'm going to put my 9/10, my 200ths, and then I'm going to add a 0 or place a 0 in the thousands place. That missing place value. Why? Because 104 and 1/1000th is representing this place value. Next, we're going to go ahead and place the number 73 here, and then don't forget, you're probably going to have to borrow from the ones here because, as you can see, you can't take 9/10, 2 100ths, and from 0/10 and 0/100ths. Problem number 11. Another ratio. So once again, I would recommend creating a ratio as a fraction, numerator over denominator. So for every 3, and you can even label it 3b, we have 5g. Okay, that's for every 3 boys, there are 5 girls. So basically, that's a 3 to 8 relationship, meaning 3 out of the 8 kids are boys. A 5 to 8 relationship would be 5 girls for every 8 children. So basically what they're asking is, the next example, are these ratios equivalent? So what you want to do then is you want to go ahead and write the fraction 12 over 15. So you basically have 2 different relationships between boys and girls, and then apples and pears. So what do we see? Well, we see that 3 times 4 does equal 12, and then 5 times the same number, 4, has to equal 15, and it does not. 5 times 4 does not equal 15. So these are not equivalent relationships. Remember the word equivalent, equal or same. So you would say no and why. The next example is, once again, showing you a relationship. This is basically 7/3, and as you guys know, when you divide fractions, you're going to be multiplying by the reciprocal. The word reciprocal kind of throws kids off, but basically what you're doing is you're just flipping the numerator and denominator. So as you guys know, 3/4 turns into 4/3. Please understand, Illuminate will probably ask for a simplified fraction. So 28/9 is an improper fraction. You need to think to yourself, how many times will 9 go into 28 and then there is a remainder? So as you guys can see, 9 goes into 28 3 times. So you have 3 is the whole number. I'm running out of room. The remainder is the numerator, and then the denominator stays the same. So 3 1/9. They will ask for a mixed number. They will not give you credit for an improper fraction. Problem number 13, if Jaden has 4 cups, as you can see, I'm underlining all the important information. So 4 cups of oatmeal, he divides it by 2/3. So 4/1 is how you would write a whole number as a fraction, and then we are dividing this by 2/3. So we're not done, because now what we need to do is multiply by the reciprocal of 2/3. So multiply by, and that's 3/2. And then once again, you're going to get an improper fraction. This will go in nicely. I made a mistake. I was actually thinking about the answer. There you go. 2 will go into 12 6 times, and there you go. There's the whole number, 6. We've done this multiple times. Once again, just write out the problem. A lot of times, students will not check their work when doing division. I would definitely recommend doing that, and I'm going to show you a strategy to do that. Sorry about the scratch pad and the numbers. They're a little funky, but basically, once you've solved out this problem, this is the divisor, and then this is the quotient. If you multiply the 2 circled numbers, we don't know what this number is because I've not solved the problem, but if you multiply the divisor and the quotient, you will get the dividend, 26,455. I would definitely recommend doing that. Greatest common factor of 48. What I would do is I'd write out all the factors of 48. So 1, 2, we have 3 times 16 is 48, so we would write 3. 4 goes into 48 12 times, so that's a factor. 5 is not a factor. 6 times 8 is 48. So basically what I'm doing is I'm writing all the numbers that I can think of that I multiply another number by to equal 48. And then I do the same for 84. 1, 2, you'd have to check. 3 times, I believe, 28 is, that's a tough one. 3 times 28, I believe, is 84. So, yep, that is. So what we keep doing is we go through and we think about all the numbers that are going to be multiplied by another number to equal 48 and 84. And then, as you can see, the greatest. So once you have all the factors written, you look for the largest number. I know that 7 times 12 is 84, so we would have 7, we would have 12. You know that half of 84 is 42. So what you're doing is you're writing all the factors, and then ultimately, as you can see right now, so far, 12 would be the greatest common factor. There could be a larger number. 48 doesn't go into 84. So with that being said, yes, that would be the correct answer. These aren't going to be the same numbers. So use this strategy of writing out all the factors of these two numbers and figuring out the largest one that both of them share. 30%. Remember, 30%. When you think of percent, think of out of 100. And so 30 out of 100 is 0.30. You would multiply that by 240, and that's going to tell you what 30% of 240 is. I'm running out of time. I've got 30 seconds left with you. You can see that I believe this is a division problem. How many times will 11 go into 517? Very straightforward. We've talked about adding decimals, making sure that you line up the decimals. And once again, I have 15 seconds left, and I am done. Awesome, guys. Well, hey, good luck. Thank you guys for taking a look at these problems, and I know you'll do great. Enjoy.